Do we have to correct it?
Yeah, we're gonna make some corrections. So I'll give you the answers. I want you to make corrections if you have something wrong on your worksheet.
Wait, were we supposed to finish all of it?
Well, I told you the first 2 pages.
Oh, okay.
So,
Yeah, I did 3.
oh, okay, so you went ahead. Yeah, because
Address?
yeah, I just said the first 2 pages for homework.
Do you think
Yeah.
we could go over 8 and 10?
Well, I'll be going over the first 2 pages. Like, we're gonna go over all of it. Like, so we'll go over everything you have questions on. So, sorry, what?
What if you didn't fill in one?
If you didn't fill in one, it'll be wrong at this point, but you can write in the right answer. So I want you to mark I want you to make corrections. Everybody have their worksheet out? Okay. Okay, so the first page is what has the number 1 CH4 plus O2. Let's go through those ones. So a few of these are already done, but just to make sure you have the right answers. The one that says CH4 plus O2, we're gonna start with that one. Should be the first page from your handout. Yeah, there's the first one that says CH4 plus O2. That's the one that we did first, right? That was the first page.
Page 4, yeah.
I don't have that one.
You don't have that one. That's the first one we had yesterday.
Wait, did you give us 4 sheets?
Well, I gave you a lot of sheets. But the first one that I showed you, remember I showed you on the board that first one, it was CH4 plus O2. That was the first one I did on the board for you all. You did the rest on your own. Should have been the first page you worked on yesterday. Okay, everybody have that? So let's go through them today. So for the first one, again, I'll just go through the ones we already done too, just to make sure you have them all. Number 1, I'll just say the numbers. So if there's nothing you need to put down, you could just leave it blank. Now I will just say 1 just to make it easier than saying blank, but you don't need to write anything down. You can leave it blank. So for number 1, it's 1, 2, 1, 2. But again, you don't need to write 1s in. Number 2, it's 2, 2, 1. Number 3, it's 4, 3, 2.
Wait, what did, number 2 is blank, blank, blank.
Should it be 1, 1, 1?
So wait, number 2?
Yeah.
Number 2, wait, hold on.
NaCl.
Why didn't it? Okay, this answer sheet is wrong. Sorry about that. That's weird. I was reading out the answer sheet, but that's the wrong answer. Yeah, no, it should all be 1s. So I'm gonna make that correction here. Speaking from it online, just you can't trust anything from the internet. Okay, so yes, they should all, number 2 should all be 1s because that's just Na and Cl and NaCl. Number 3, 4, 3, 2. Number 4, 4, 1, 2. Sorry, not 4, 1, 2, something else. Number 4 is 1, 3, 2. Number 5, 8, 17, 1, 8. 8, 17, 1, 8. Number 6, 1, 3, 1, 3. 1, 3, 1, 3. Okay, so that can also happen. But if you put down 2, 6, 2, 6, you can divide them all by 2 to get that. So that's what you should do. So I'm going to make that correction because if you can reduce, it's like a fraction that's 2 over 6. You want to reduce it to 1 over 3. Same thing here. So if you can reduce them, you need to reduce them. So the correct answer is 1, 3, 1, 3. Number 7, 2, 1, 1, 4. Number 8, 2, 6, 2, 3. Number 9 is 1, 2, 2, 1. And then 10 is 1, 5, 1, 4. Any questions about those ones? Okay, next page. So what is the one you had after this one? What's the first? SiCl4. Okay, so everybody have that one? SiCl4 is the beginning one? Are you ready? Okay, so for number 1, it's 1, 2, 1, 4. No.
Can you repeat?
1, 2, 1, 4. Number 2 is 2, 6, 2, 3. Number 3 is 1, 3, 2, 3. Number 4, 1, 6, 2, 3. Number 5 is 3, 2, 1, 6. Number 6 is 1, 4, 1, 2. Number
4 is 3, 2, 1, 6.
no, number 4 is 1, 6, 2, 3.
Oh.
5 is 3, 2, 1, 6.
6 is 1, 4, 1, 2. Number 7 is 1, 2, 1, 1. Number 8, 12, 1, 4, 6. Number 9, 2, 5, 2, 4. Number 10, 2, 2, 1, 4. Anything you want me to go over on
Number
those?
10 was 2, 1, 1, 4.
Number 10 is 2, 2, 1, 4.
Okay. Wait, 2, 2, 1, 4?
Yes.
I got 4, 2, 1, 1, 6.
Okay, let me check. This could be also a wrong answer too. Let me check this one. Okay, so for this one, so what did you put down, Lauren?
2, 1, 1, 4.
2, 1, 1, 4. Okay, let's see.
So both
Okay,
are
so for that one,
2, 1.
that would be correct. It's also, wait, hold on.
Is that in the end?
If you have it like that, if you have it as what you said, Lauren, where it's 2, 1, 1, 4, you have on the right-hand side 2 ends. Yeah, and you have 2 ends on both sides, so that's balanced. Then you have 8 H's on the left, 8 H's on that side, 6 O's, and then you have 4 plus, yeah, so it's also wrong. These are just, yeah, sorry about that.
This might be me, but I think
Number
number
9?
9 is also wrong.
So number 9 said 2, 5, 2, 4.
It's right.
But somebody, what did you all get? That was, you said that was different?
Well, I erased what I got, but
I got 1, 2, 1, 2.
1, 2, 1, 2 for number 9?
Yeah.
yeah, that's what I think.
So you said 1, 2, 1, 2. Let's see if that works. So for that one, if you have 1, 2, 1, 2, so you got 2 ends on the left-hand side, 2 ends on the right-hand side. You would have 4 O's on the left-hand side. You would have 1 plus 2. You only have it's 4 O's on the right too. 4 H's on the left. Only 2 H's on the right. So that would. Oh wait, sorry, no, 2 and 2. Never mind.
No, it'd be 2
Yeah.
and 4. Oh, wait.
Yeah,
sorry.
you'd have, so that looks like it would work.
Wait, then can you
I
do
don't-
2, 5, 2, 4?
No, I got 1, 2, 1, 2.
I know, but can you try the other one?
You said 2, 5, 2, 4.
2,
Because that's what the answer was on here. Let's see. So then you got 2 times 2, you got 4 ends on the left-hand side. You got 4 ends on the right-hand side. You have 5 times 2, you got 10 O's on the left-hand side, plus 2 more, you got 12 O's in total on the left-hand side. Then on the right-hand side, you got 4 times 3, 12 O's on that side. H's, you have
The O's wouldn't work.
4 H's, and you have 4 H's. So,
So
yeah,
for Marinas, would the O's work?
what did Marina say? Oh, she said 1, 2, 1, 2. So we have, 2 times, we have 4 O's plus, yeah, so we only would have actually, that would just be 5 O's on the left-hand side.
Oh, yeah.
Yeah,
So.
because you got 2 times 2, you got 4 O's plus 1 more, you got 5 O's on the left-hand side. And you only have 6. So,
Oh, no.
yeah, so actually that wouldn't work. So no, the only answer is 2, 5, 2, 4. Anything else? Okay. So the other ones just keep for practice. You can study for the test. You can keep those ones. Number 7 on the first page. Number 7 is 2, 1, 1, 4. Yeah, just keep them out. I'll take them up after class. But the ones you did turn in after, just hold on to them after.
Can I staple them though?
Just hold on to them because I'm gonna make them right now. But after class, I can staple them for you. Anything else? Okay, so let's go on to the lesson for today. We're going to take a few notes of chapter 10 and then do a few homework problems.
Do you have anything to do on Friday?
In chemistry?
Yeah.
I can check. You mean of last week? Yeah, for Easter Monday?
Yes.
Yeah, I have some questions for you to work on, probably 14 through 20. Yeah, probably. I mean, we'll see how class goes, but that's the plan. No quizzes, no. Okay, so 10.1 today, chemical reactions. Oh, I'm sorry, my notes said, I'm looking at old notes and the chapters went out of order, but yes, it is 9.1 in your book. So the equations we looked at describe chemical reactions with symbols. Yeah, you'll get to do that pretty soon. Yeah, you'll get to see lots of reactions. Should be fun. Yeah, there should be, yeah, there's some really cool ones we're doing. Pig dissection. I mean, I don't think the smell for pigs, I don't think it's too bad. Some of them, it can be pretty bad. But not all of them are that bad. Okay. In a chemical reaction, atoms are arranged and rearranged to form different things. So in any chemical reaction, you have a rearrangement of atoms. So the rearrangement of atoms provides different substances, different compounds, different properties. So there are indicators you can see that show reactions taking place. So some things you would look for to indicate the reaction taking place would be a temperature change. So when you think about temperature change, usually we think about things getting hot, like in a fire, for example, or an explosion. That's definitely the case. Reactions can definitely make things hot, but also things cold. There are reactions that make things colder. An example would be ice packs. Like if you ever had those ones you twist to open, that one is a reaction taking place when you do that. You have in those cold packs, what you do is you have these two compartments. And on one side, it's just water. The other side, there's pellets. And have you seen this before? You have there's pellets on one side and on the other side. And then you crack it, you twist it. Hit it against the desk. I mean, it sure could. I mean, yeah. I mean, like any kind of, yeah. Yeah. Yeah, I mean, that's unusual. I mean, usually you just twist it, but yeah, I mean, you could also do it that. And it was a cold pack, right? Yeah. And so usually what they have is ammonium. I think it's nitrate. It's either, I mean, you could do either one. You could do ammonium chloride or nitrate, but I believe it's ammonium nitrate that's in here. And it's a salt that when you put it in water, it cools it down. And so these cold packs, that is chemical reaction taking place, where ammonium nitrate reacts with the water to make it colder. There also are hot packs that, just do the opposite. Like you have some hot packs, they have these black pellets in them, and it's iron. and it reacts with the air. So when you open up, when you take off this tape, then the iron is open to the air, and iron reacting with oxygen creates heat. And that's what makes those hot packs work. So those are some chemical reactions that we can use that change temperature. So it might be surprising to hear that there are some reactions that take place that make things colder, but there are many reactions that do make things colder. That's one example of one for the cold pack.
How does it make it colder?
Do I know?
How does it make it colder?
How does it make it colder? By when the bonds are, so when this happens, when you have a reaction taking place, bonds are broken to make this happen. And so when you are breaking bonds, energy is either released, like with fire, energy is released to create the fire. When you release energy, you get heat, or energy is absorbed. So this cold pack, what it does, in order to break the bonds, it takes in heat from the surroundings to break the bonds. When heat is taken in, it gets colder in the surroundings. And so it's absorbing heat, and that makes it colder.
So iron and oxygen absorb the cold?
No, cold's not a real thing. Cold doesn't exist. It's kind of like saying you like a hole in a wall. Like that hole is actually nothing in the wall. The hole itself is nothing. It's an empty space. The wall is what's real. Same thing with cold. I mean, cold is the absence of heat, or dark is just where light is not. So dark, cold are not real things. There's just the absence of something. And so heat is actually what you can measure. And if things are cold, they have less heat than things that are hot. But heat is transferred. But you can't talk about cold being transferred. So temperature change is an indicator of reaction taking place. Other things, heat being given off along with temperature change, light being emitted, like in fire, for example, a color change. If you see a gas being produced, if there's an odor being produced, if a solid appears, so sometimes I'll show this reaction to you, I think on Friday or maybe next week, but there's some reactions that take place where you can get two liquids, pour them together, and you get a solid produced. And so that would be an example of reaction. And last semester you did this with copper wire. Remember you put copper wire in a solution, it turned blue, and you got silver produced on it. So that's a solid being produced in that case. Okay, so we talked about this the other day about the symbols on the chemical reaction. For example, if you're looking at iron reacting with chlorine gas to produce iron chloride, lots of times chemists like to put in the states of matter. And so sometimes you'll see on these reactions, you'll see S for solid, G for gas. It wasn't 10 minutes. No. It's not that long. Oh, it's not balanced. But yeah, so you can have any combination of things. So you could have any, but as it is, you're right, it's not a balanced equation. So we need to go back and balance it. What do you mean a number next to it?
Like Roman numeral
Like
three.
Roman numeral 3,
Uh-huh.
like Fe3 or iron 3, like would it be Fe3? Like, would it
So It depends on your context when you're talking about. So you're talking about like if you had say iron 3 chloride. So this tells you the charge of it, right? So it says it's Fe3 plus. But well, we can use this to get the number. So the subscripts, because Cl is -1. So you would need 3 Cls to counteract the positive 3. So this would become FeCl3. But if you had iron 2 chloride, then that would mean it's Fe2 plus Cl minus, put the 2 down here. So this would be FeCl2. Yes. Slime? No, that's yeah, we need to talk about what aqueous means. Aqueous means dissolved in water. So I'll write that down here. So aqueous means that you put something in water and dissolved it. So for example, if you put salt in water, salt is now aqueous. So you could have, table salt's formula is NaCl. So if you have solid NaCl, that's just the white crystal that you see. But if you put that salt in water, now it's dissolved in water. It looks like it's a clear solution with the salt in it. That is now NaCl aqueous, where you've now put it in water. And so it would look like a solution where it would look just like a clear solution. You have that salt put into water. That's what aqueous means. Well, the solution itself is made of water, but you have salt dissolved in the water. Okay. So what we're going to be doing today is doing the reverse of yesterday. So yesterday we had equations written out for us. We had to balance it. Today you're going to be given words, and based on the words, you're going to write out the equations. So on page 287, let's go through example. They're going to give you the names of the compounds, and you're going to write out the compounds based on the names they give you. So example problem number 1 in the green box. So it says write a balanced equation for the reaction in which aqueous sodium hydroxide and aqueous calcium bromide react to produce solid calcium hydroxide and aqueous sodium bromide. So just go one by one through here. Sodium hydroxide. What formula would you have for sodium hydroxide? Good. So because your sodium is +1, right? OH is -1. So you just need 1 Na and 1 OH. Sodium hydroxide, just NaOH. And it says it's aqueous. So we would add AQ and aqueous calcium bromide. Okay, so calcium bromide, we would start by writing the symbols with the charges. Calcium +2, bromine -1, and then switch around the numbers. So we get CaBr2 for calcium bromide. And that one is also aqueous, it says. So add AQ. It doesn't matter. Might as well just do it now. It wouldn't make a difference on when exactly you put it in, but you should put it in sometime in the reaction, so might as well just put it in as we're going along. It says it reacts to produce. So when you hear that, or when you read that, you're going to show an arrow. Now go into products. So it produces solid calcium hydroxide. What formula would you have for solid calcium hydroxide? CaOH2, very good. Yeah, because calcium is a +2 charge, hydroxide is -1, so you need 2 hydroxides to cancel out the +2. It says it's solid, so we have to include an S. And then it also produces aqueous sodium bromide. NaBr aqueous. So that is our equation, but we also need to make sure it's balanced before we finish. So just go one by one through these. We have one Na on both sides. We have, for O's, we have one O on this side. We have two O's on that side. And then we have one H on this side, two on that side. So we can start with putting a 2 in front of here to balance the O's and the H's. Now that that's balanced, we can see, well, now we have 2 NAs right on this side. So we can put a 2 over on this side. So now we have 2 NAs on both sides. Last thing would be the BRs to check. And yes, the BRs 2 and 2 on both sides. So that is our complete reaction. And that's how you do this. So just like yesterday, just one more step where you would write in the formulas that are given to you. Before you start the questions, one thing I want to point out to you is that there are diatomic elements. I mentioned this to you before, I forgot if I did, where there's H2, O2, N2, Cl2, Br2, I2, and F2. Did we go through this before? No? Okay, so these elements, when you have pure hydrogen or pure oxygen, when they say that, like when they say that for number 5, for example, it says liquid carbon disulfide reacts with oxygen gas. When they say oxygen gas, you don't write O, you write O2. Because oxygen, when you're dealing with oxygen, it's going to be as O2. It won't just be as O. So these are the diatomic elements, which if you have them on their own, they would not just be 1, they would be S2s. So be aware of that one. Everything else, though, I think is straightforward. So on page 287, do 4 through 6 for right now. And then we'll go through the other ones later, but for now, 4 through 6 on 287.
Miss Holly.
Sorry, 1 second. Yes.
For each element, you have 2 atoms.
Oh, yeah. Here, let me help them on Zoom really fast and I'll answer your question. Yes, sorry, what was your question?
Do you mind showing the board again for the diatomic elements?
Oh, sure. Yes, I can do that. Okay.
Thank you.
You're welcome. There you go. Okay. So what was your question?
For these, so it's one element has 2 atoms.
Yeah, so what this is saying is that if you have just hydrogen gas, for example, you would write as H2, not as H. So like if you look at number, do you have the ones we were doing today in class? This one, like if it's this with this, when it says oxygen gas, it would be O2, you'd write, not as O.
Okay.
So, but if it says like carbon, for example, just be carbon, just C.
Why is that though?
They're not stable on their own.
Okay.
The electrons aren't stable as, so those are the ones that are only stable when they exist as 2s, but they can't be stable on their own.
Okay, thank you.
Oh wait, sorry, did you still need it, Allie?
Oh, sorry, no, thank you though.
Okay.